Today we are going to talk about erosion. Erosion is basically the process where water or wind runs across a surface and carries parts of that surface away. So when the rain flows down from the mountain, it might carry dirt, it might carry leaves, it might carry rocks down with it. A natural process, but one that has big effects for the people that live near the water. One of the first things that we talked about at the start of the year were the four spheres of the Earth: the hydrosphere, atmosphere, geosphere, and biosphere. And all year we have been talking about how those different spheres connect and interrelate. We're going to look at that in a little more depth. We're going to start out looking at the natural world and then think about how it affects the human world, part of the biosphere, and then think about how ways that humans try and manage the natural world. We're going to start out talking about the water cycle and how the hydrosphere affects the geosphere. So, as a quick reminder, the water cycle was where the sunlight evaporates water. Okay, the water condenses into clouds. Okay, that condensation falls to the ground as precipitation. Okay, and as precipitation, it runs downhill. Okay, so if it starts up here at the top of the mountain, it runs downhill to water, to a stream, ends up in lakes, which end up in rivers, which end up in the ocean, where it again evaporates, condensates or condenses, precipitates, and then it runs off. Okay, and that's where we get the idea of a cycle or a circle of water. Now, if a bit of water falls on this side of the mountain, it's going to end up over here. But if a bit of rain falls on the back side of the mountain, it's going to end up going in that direction. All right, let's take a closer look at what that means. This is a map of what are called the watersheds in the United States. Let's make this full screen. Okay, so this is a map of the watersheds. Each of these, let's circle one. Each of these areas, okay, is its own watershed. So within that region, all of the water that falls and touches the ground within this region all drains to the same place. And in this region, all of the water that falls drains to the Chesapeake Bay, right? So we are part of the Chesapeake Bay watershed. So let's zoom in and take a little bit of a closer look. All right. So here is Washington, D.C., right here. Okay, this, of course, is the Potomac River. Okay, here in Washington, D.C., we know we also have the Anacostia River, and where they meet is Washington, D.C. But all of the water that falls up here in the Appalachian Mountains, over here in Virginia in the Appalachian Mountains, it all eventually drains toward the Potomac, where it ends up draining into the Chesapeake Bay. Right? And this river drains into the Delaware Bay, but it's all basically going to the same spot, to the same place. Right. And if we zoom back out, we can look at, this is what are called the major hydrologic areas of the United States. Right? Some of them are very large, like this is a massive area that drains. Okay? And all of this actually drains into the Mississippi, which runs here. Okay? All of this is a different river system, but it also drains into the Mississippi. The Mississippi is one of the major river systems in the United States. So basically think about it. Rain falls here, it enters the ocean here. Rain falls here, it enters the ocean here. So all of this area, a large part of the United States, flows out here, right? And so on a human scale, if we have a construction project here that dumps pollution in the water, right, you have the potential of affecting all of this area, including the water in the Gulf of Mexico, all right? But the basic idea is water always runs downhill, eventually runs into streams and collects, but it always runs downhill. So let's take a look at this. This is called the Gunnison Basin. Okay, and we're going to zoom in a little bit so we can see it better. This is a topographic map. I'm not sure if we've talked too much about topographic maps, but up here is a key. Let's make this a little different color. So up here is a key, right? So things that are blue are still 4,500 feet high, okay? But that's low on this scale. So blue would be here. Notice that's where the streams are, in the lowest part. Okay, things that are this brown are highest. That's about 10,000 feet. And then the white above it is 14,000 feet. So look here, that's the highest. Right? Water flows down into the low areas. So this map, the colors in this map help us see what's high areas, what's low areas. So water is going to flow down. It's going to flow down towards the lower areas. Now, this stream system, right, is going to flow like this and keep going and eventually reach the ocean. But everything in this area drains down the slopes to this river in the bottom of the valley and flows towards the ocean, right? And so it could be kind of low water here, but if it rains over here, that water is going to flow down to here. And let's take a look at what can happen when you get a lot of water flowing like that. So this is in Utah. A couple of things to note here. Look at the way the earth is in lines, is in horizontal bands. That is evidence of, water and sediment millions of years ago. Okay, and then you can actually, there's a lot to talk about why that is all at the angle it's at and what all of that rocks mean. But we're looking at the river today, right? The river looks fairly calm, fairly low. But let's listen to what this guy has to say. He's here to observe what happened. So think about it. Areas like this, look at the sides of that stream. They're very vertical. So when it rains 100 miles upstream, you know that water is going to make its way downstream. It can actually be very dangerous to be in canyons like this when it rains upstream. This guy knows how much it rained and how long it took to get here, which is why he's here filming it. But this sort of thing happens everywhere. It's just in canyons like this, the effect is amplified, and that makes it easier for us to see it and notice what's happening. So notice the water at the front edge, right, which is the water that's been here, is lower, it's calmer. Okay, this water back here looks muddier. Okay, you can see branches and sticks and things in it, right, because this water back here was from runoff from somewhere upriver, and it brought dirt with it, it brought sticks with it. That's all erosion. So when the water runs downhill, it picks things up. If it's slow water, it can only pick little things up. But if you have a steep slope, if you have a lot of water running, it can actually pick up big things like lots of dirt, trees, rocks, cars, things like that. So this front edge, this is actually the edge of the floodwaters that are coming downstream. Also, you can notice in the sound, right? It was calm and quiet before, but the roaring of that water as it rushes tells you that there's a lot of energy in that water. Okay, lots of dirt, lots of debris. Again, all evidence that the erosion pulled all of this stuff downstream. I mean, those are big, like, tree stumps. Okay, did you notice what happened? He turned the camera on to try and capture it. Let's look at it again real quick. When he brings the camera back here, part of the bank is actually collapsing. Right, the force of the river is higher than normal, and it's a lot more forceful than normal. So it actually eats away at the soil and causes the river side to collapse. There it is. Big chunk of the stream, I'm sorry, the river edge just collapsed into the stream. Again, normally there's not enough water to do that. Here's another one happening. But with this much water flowing down because of the rain, you can get these big erosion events. So you would not want to be anywhere near that edge when it collapses, right? Because you end up in that water, the water's flowing nice and strong, super dangerous. Again, this is why I said, like, the canyons like this can be dangerous during rainstorms because it amplifies the force of the water. And if you look at the weather, it's super beautiful out, calm, collected, but rain 100 miles upriver, 10 miles upriver, or yesterday can have strong effects downriver and downstream. All right, so that is a natural erosion. Okay, that was just rain coming through that valley to show how, again, the force gets amplified. These kids built a little dam, and they built it where they knew that the tidal flow was going to fill it up, and then when it was time, they could kind of break the dam with a little bit of a flow, and well, we will see what happens. So just a tiny little crack, right? It's just a little rivulet, just a little stream. Okay, not that big of a problem. Notice the edges of the stream are starting to collapse inward. All right. So there's a lot of water behind it. So the water wants to flow. Water always wants to find the lower area. Notice that it's digging away more and more at the walls, the sides of what's now the stream bed. Just from that little bit of a start, it just builds and builds and builds, erodes away the edges. The more it erodes, the bigger the hole gets. The bigger the hole gets, the more it erodes, etc., etc. And again, it looks like it's slowly collapsing. Okay, more and more water is coming out. You can see how there's the front edge of that stream, just like we saw in the last video. And there it goes. Now it's starting to collapse faster and faster. The faster it collapses, the more water flows. The more water flows, the faster it collapses. So again, if you look at how much water is still in that tidal creek, okay, there is lots and lots of water. So again, where that water is now is actually where Thomas was standing a moment ago. So there goes all of that floodplain, so all of the flat areas, because all of the water is coming at once instead of being allowed to go when it wanted to. We're going to skip ahead just a little bit. So again, think this whole area was covered by a dam, and that little bit of a start amplified and amplified and amplified, and that's how we got this giant stream from that little bit of a flow. A little bit of a flow turns into a big bit of flow, destroys the whole area. You might think, well, that's just kind of like man-made. They amplified it. They did that on purpose. Well, it happens naturally as well, right? So, especially in northern forests, you have a lot of ponds and lakes like these that are created when beavers will create a dam, and the beavers create a dam because it allows them to more easily move through the area to collect the tree bark that they eat. And so these beaver dams hold back the water, create these, I guess, natural but animal-made ponds. Okay, but then occasionally these dams will also collapse. Right? So here's some great drone footage of just how big of an area this beaver dam caused a flood. So the beavers are actually changing the landscape by causing this pond to be formed. Changes what can live there, of course, because the trees and the other plants can't live in the middle of the water. And when the beaver dam, so basically the beavers will maintain it, but if the beavers go away, or if they pass on, they move away, they aren't around anymore, the beaver dams can start to collapse. And that same process happens, right? It starts out as a little bit of flow, but there's so much water, it can wash away entire trees. So this entire pond is now going to want to drain out that little hole. You can see how quickly that water is moving towards the drainage area. And now what used to be a forest, right, maybe a little bit of a creek, is now a raging torrent. That's going to wash away dirt, it's going to wash away soil, it's going to wash away the plants, right? And then the forest, again, because it's part of a natural process, the forest will recover. It's all part of the natural cycle, but think of how much force is in that water as it flows. If people want to live near water, we have to figure out ways to deal with this sort of event. If we live near rivers, we don't want our houses to collapse in the river. If we live near the ocean, we don't want our houses to collapse into the ocean. Let's take a quick look at something like that. All right. So we're going to take a look at Ocean City, Maryland. All right, because I found something when I was exploring I want to show you. So we zoom in on Ocean City, Maryland. Right. And so you can see the eastern side, the right side is beach. On the western side, the left side, that is all salt marsh. but the city is built up all on this spit of sandy soil. So if this area here were to erode, it could destroy these buildings, right? And so in order to have a city here in Ocean City, people have to manage the erosion in different ways. And we'll get to that in the future. But what I wanted to point out was this little bit of land here, right? One of the cool things about, one of the cool things about Google Earth is you can take a look at the past, okay? So this is the same exact area in 1985. It's really blurry, so it's hard to see, but you can see there's a lot more land there. Okay, let's move it up a little bit. So let's look at 1989. That's a pretty large island, right? And look at the shoreline of Ocean City. It doesn't look as smooth. If you look carefully, there are these vertical parts that stick out from the shoreline. Those are designed to keep the soil from eroding away, right? And we will talk about those. Let's move forward a little bit. So let's look at let's say 99, a decade later. No different. 2002, 2005, 2002, the island's still pretty much there. 2005, it's pretty much mostly gone. My guess would be somewhere between 2002 and 2005, there was probably some sort of a large storm. I bet if we went to historical record, we can find it. And that started to wash away this island because there was nothing keeping it together, which is a natural process. But again, if people had built on that island, then that becomes a concern, right? So it's pretty stable until 2017 when it starts to get a little bit smaller. And these days, it's like this, all right? So the key to notice when we're looking at that island is around 2004, where is it? 2002, yeah, 2003, 2004, it went from a fairly large area to a pretty small area. And it shrank a little bit, but it became pretty stable after that, getting smaller and smaller every year. But this was a pretty catastrophic event. And that's how these things go. When you get a lot of water movement, a lot of energy, you get a lot of erosion. All right? Again, a natural process. But in the next couple of weeks, we're going to talk about how that affects where people live, how we build the things that we build, and what choices we make about who lives in what parts of the city. Right? There have been some big effects in the population of various cities because of flooding that has been affected by how we've decided to try and stop flooding. We will get to all of that, but for now, I just want you to think about what happens to all of the water the next time it rains. Okay, take a look and see where you see it flowing. In your neighborhood, you will notice it go from the high areas to the low areas. And I want you to start paying attention to that.